Okay, so just for the completion, I will just go into first one, right? So here timers counters, right? A timer is a register, so 8-bit to 8 to 16-bit SFR, right? So we can start it from 0 and it will go up to 255, then an interrupt will generate, then it will reset to 0, right? Then here in a timer, the starting value is 0, maximum value is 255 for 8-bit timer, right? So in here, this is one example when we can use timer. It has a timer in order to measure time, right? So what we are doing is when you using this timer, when we have a known clock pulse, we know the frequency, right? We know the frequency. So if we know the frequency, we know the periodic time, right? Periodic time we know. So if we can count number of clock pulses, then if we can multiply it by the periodic time, we can measure the time difference. Right? So there are some settings that um, can set like 16 clock pulses count as 1, or for 16 clock pulses time is incremented by 1, or 8 clock pulses time is incremented by 1, or 4 clock pulses time is incremented by 1. So by using that, what we can do is we can measure more clock pulses. That means more time we can measure. Right? So here this is an example for a counter. So this is the push button. So when we push this button and release it, something like this. So uh, mm, this is the pulse generated by this external source. External source is the push button. Push button will have, right? So therefore here you can see this T1 and T2, they are not equal, right? Because someone has pressed that push button according to their requirement. So therefore it cannot use this as a measure time, but what we can do is we can use it as to measure number of pulses, right? So measuring number of pulses means it is acting as a counter. So their usages are, we can use it as a product to count products on assembly line, number of axis rotation, number of passengers, so like that. So in here, if we have uh, pulse, we have two things, right? This is called the falling edge and this is called the rising edge. Falling edge means going 5 volts to 0 volts. Rising edge means going from 0 volts to 5 volts, right? So this is the watchdog timer. Watchdog timer is an RC oscillator within the microcontroller. It is why we are using it is, so if the watchdog timer is enabled, it increments its value with the RC oscillator with every time it counts up to the end, right? The microcontroller reset occurs and the program execution start from the first instruction. So as I have explained, so this is the microcontroller, right? This is the microcontroller. In this microcontroller we have the program. So somehow if that program has changed to something like this, an infinite loop. So even though this is our program, even this is our program, let's say this is where we have that while one loop, mm, and while one loop. So if that happens, our program, anything, all the other places, they will not execute. Why? Because we are stuck in here, and let's say if we are very close to the place, we can do the changes, right? But if it is critical and if it is at a distance place, we cannot do any change to this. Why? Because uh, this is an infinite loop. So therefore what we need is we need to get out of this while loop. So we should have a backup plan to get out of something like this happening, right? So therefore what we are going to use is we are going to use this watchdog timer. We call it as this watchdog WDT as well. So what is happening in here is if we enable our watchdog timer, what will happen is um, here it increments its value with the RC oscillator. So there's an RC oscillator for watchdog timer. So it will measure the number of clock pulses, right? And every time it counts up to the end, right? So what it does is, if we enable that thing, right? If we enable that thing, um, so the microcontroller, it will reset and occurs, and the program execution will start from the first instruction. So when we enable our watchdog timer, so that RC oscillator will count it separately, right? So therefore, after some time, what it does is it will reset everything, then it will start the program starting from here, right? So therefore, now we are out of this while one loop, right? So something like that. So that is what is done by this watchdog time. Okay. Hope you can understand. Okay, so here we'll consider an example, right? Okay, so example 5. Is this example 5? Okay. Um, Let me check. Okay, so let's call this as example number 5. I'm not sure that is example. So here, this one, so timer 0, right, is used as a counter, right? The counter input is connected to a push button, so that any button press causes timer 0 to count one clock pulse, right? When the number of pulses matches the number stored in the test register, a logic 1 or 5 volts appear on the pin port B, pin 0. This voltage activates an LED in the program. So this is the program that we are going to write, and we are going to implement the mm, uh, implement it on Proteus, right? So here we are going to, what this basic thing is, we have a push button, right? We have a push button, right? And that is connected to where? That is connected to okay, a timer 0, right? And it will give the input to time 0, right? So if this value is equal to the test register value, so that means this is a constant, right? Constant. What should happen is, for port B, right? Bit 0, right? There's an LED connected, right? LED connected, so it will give 5 volts to that, right? So then we can decide whether it measure the number of pushes in this push button, right? So that is what we need to do, right? So here when we have that our timer, right? So in order to control our timer, what we have is something called this option register, right? Option register, there is the register in here, right? Register in here. So we'll understand these relevant things one by one. So here this is bit 0, this is bit 7, so this is 6 5 4 3 2 1 bit 0, right? So here TOSE, TOCS, right? Here this is PSA, PS2, PS1, PS0, right? So those are the basically things that we need in order to control our time, right? So we'll go one by one. T0 CS, timer 0, clock source select bit, right? So what is that? There is this, right? bit 5. uh, Timer 0, clock source select bit, right? So this bit determines the clock source, right? This bit determines clock source. We can determine if the timer will work with the system internal crystal clock or an external clock, right? So uh, in here actually what we are doing is we are not going to use it. So actually we are going to use it as a counter, so therefore we need um, uh, we need it to be uh, mm, right? We need it to work with, let's go, external clock. External clock means so transaction on TOCKI pin, right? So I'll show you, right? What is that? Then internal instruction cycle clock. Okay, I will show that one. Okay, so just need to show you this, right? If you take a look at this that data sheet, right? Okay, so here can you see that in here RA0, right? RA0, can you see RA0? No, sorry, RA4, right? RA4, yeah, can you see in here RA4? RA4, that is bit number is 6, right? Digital IO open drain when configured as outputs. Here you can see timer 0 external clock input, right? Timer 0 external clock input. So yeah, if we just okay, so here can you see that we have timers. So that means we have pins to sorry, we have registers to record the time, right? Okay, so here can you see that for the other places also, here you can see timer 0. There are several timers, right? You can see this, right? Several timers. So we are going to use the timer 0, right? So in timer 0, timer 0. So other than that, here port C you have timer 1. Yeah? Then here is timer 1 and timer 0, right? Yeah. So can you see that is special function register? So time 0 is this register. Can you see? It is this one. Yeah. 0 1 timer 0 module register. So here how many bits it has? 8 bits, right? Here timer 2, right? Right. Okay. Here this is the option register. Right. Right. Okay. So let's stop from there. Right. This is what I have to explain in here as well. Right. So that timer 0, that is controlled by this register, option register. Right. Yeah, it is registered as 81H and 181 H. We have this option register. Okay. So if you have any questions, please ask. Right. Right. So that is bit number 5. So this is TOCK1 pin. Where is that? It is RA4 pin, right? RA4 pin, where we can give a external input to input, right? Then next one, TOSE. T0SE. So it is timer 0, select H, right? Bit number 5. Number 5, right? So with this bit we can set the timer threshold response. We can determine whether the timer will respond to the fall in or to the rise in edge, right? So increment, so this is what I have explained previously, right? So here this is the rise in edge, this is the fall in edge, right? Rise in, fall in. So if I select 1, if I select increment high to low, it is falling. So it should be configured as 1. That bit should be configured as 1. For rise in, it should be configured as 0, right? So then it will measure only in here, right? Actually, if we didn't set this, it will have a default value as 1, right? But it's better if we can configure this. Okay, then next one is pre-scale assignment bit. So what is meant by pre-scale assignment bit? Uh, uh, what we can do is, right? What we can do is in here, as I have told you previously, we can use a pre-scaler, right? Scaler means pre-scaler means something like this. So here, as I have told you, if I select this pre-scaler, right, as 0, right? Pre-scale as 0. So we have to select the 0 because we are getting output from the time 0 and we are not going to use that watchdog timer, right? We are using to timer 0, right? So if we select this as 0, so this is bit number 3, right? 210. Yes, here this is bit 210, PS2, PS0, like that, right? So PS2, PS1, PS0, right? So these are bits, right? So if we select in here as 0, now we are selecting the prescaler for timer 0 module, right? Then If we keep it default, right, without selecting this, right, without selecting this, it will automatically, it will selecting this, it will automatically assign 1 to 1, and that means 1, where is that, 1 to 1, right, 1 to 1 means 1 pulse will increment timer 0 register by 1, right, default, right. But if I select this, and if we select this as all three zeros, 0, 0, 0, 2 clock pulses will count as 1, right, here 2 as 1, right. If we select as 0, 0, 1, it will select it as 4 as 1. Can you understand? 4 as 1. So if we do uh, 0, 1, 0, it will collect 8 pulses as increment the time 0 module by 1. Can you understand? So like this, right? And so up to 256 it can go, right? Okay, so 256, so it can go, so 256 clock pulses it will count as 1, right, like that. So those are the things that we need. Can you understand that part? Hope you can understand, right? So now what we have to do is, so I will first show you what we are going to do. Okay, you can see this, right? So this is our PS sorry, PIC 16F887, right? Okay, so this, so can you see that here I am connecting push button, right? So default, what is the value? Default it is 0, and default it is 0 here, and it is connected to this here. Can you see RF pin T0 CK1? So this is timer 0 clock input. This is says T0 CKI means timer 0 clock input. So on this pin, right? Pin number 6 RFO pin, port A, pin bit number 4, right? So it is connected. So this is where we are giving the external clock pulse. So here can you see when I press, it will give. So when I press it, it will give 5 volts. So when I release it, it will give 0 volts. So default is 0. So from 0 to 1 it goes. Right. So here this these are that reset and everything, right? So here can you see in RB0 we are connecting a LED. So here here we are connecting and LED, right? So LED. So here we are, what will happen is uh, mm, when this test, right, when here can you see this RB0, it says INT, right? So I will show you that one as well. Okay. So if we take a look at this program, uh, okay, here this port B, right? Port B, in port B, in this pin we are going to connect it, right? So what will happen is when this is equal to the test means it is a register value inside our peak. What will happen is it will make this H as this pin as 5 volts. So 5 volts means it will switch on this LED, right? So first of all, what I'm going to do is right. So open micro C, right? Open micro C. Then here we are going to do this, right? So in void main, right? Void main, right? So we are defining a constant. So if it is a constant here, this is the data type. We call it as char data type. So test is just a name, right? Test is just a name. So it is given the value 5, right? So what we need is when we give 5 pulses, that LED should switch on, right? So that is what we need. So define constant test equal 5. So here when we are using this PIC 16F887 PIC, right? So there are several things that we need to do. So by making this ANSEL and ANSEL H pins are 0, all input output pins are configured as digital. Digital means uh, it will take the values. It will take the values 0 volts and 5 volts only, right? So it will, so let's say 3.3, right? 3.3. So here this is 0 logic, this is 1 logic. 3.3, it will take it as logic 1, right? If it is 2.2, it will take it as logic 0, 2 volts, right? So okay, so like that. So we will get 0 volts and 5 volts only. That means digital 0, 1 only. Between those values we don't get. Between 0 volts to 5 volts we don't get. We get only the values 0 volts or 5 volts. So 3.3 means it take it as 1. 2.2 will take it as 0, because 0 to 5, that is 5 divided by 2 is 2.5, right? So like that. So therefore we need to do this thing, right? Then here we will reset our port A as 0, right? So so port A we will give as all 0, right? Then say configure port A as an input. Why we need to configure it as, okay, can you okay, so here this is the program that you need to write, right? So I didn't share it previously. This is the program that you need to write. So inside this void main, right? Void main, you have defined char test equal 5 means we are defining a constant called test, right? So it doesn't matter what is the value, right? You just need to understand that is just a constant, right? Then next one is the ANSEL 0 and ANSEL H. So all input output pins are configured as digital. That means 0 volts and 5 volts only. At 3.3 it will define as logic 1, because we have only digital 0 or 1. 2.2 it will define as 0 volts, right? Because of that. then what we will do is, so there won't be values in between 0 and 5 volts. In between there won't be value. there will be only 0 and 1. So that if we have values between that, that will be analog. So this is digital. So we need to make all input output as configured as digital. So it will take digital inputs and digital outputs. It will take digital inputs and it will give digital outputs, right? So that's that. Then port A, we are resetting that one. Then traces we will give as all 0. Sorry, all 1, because we need to configure port A as an input. Why? Um, so we are taking input from RA4, right? So we will take, because we are taking our input from RA4. So RA4, it is imported, therefore we will make everything as input. And then we are giving output to port B. So therefore, first of all, we'll reset port B, right? Then configure port B as an output. Why? Because we are connecting uh, RB0, our LED. LED, right? So start start the program now, right? Start the program. Start the program. So write this program, right? So this same program that I have given in here. Yeah, I'm not going. Actually I don't have micro C in this machine, since actually I don't have electricity, but my micro C, that part is in the in my other laptop, right? So therefore I'm doing it on this screen, this one, right? So I don't have micro C on this computer, right? So can you try to do this? So we'll test it. I have tested that one um, before the current is gone, right? So you can do this by yourself, right? So this is not the end, right? So there are several other things, right? So can you type this on and let me know whether it is working? So you can start now. Open micro C, then start a new project, right? Then type these things, right? So then you can uh, find whether you are getting the results correctly or not. Can you do this by now? Do this now. So I'll be here if you need any assistance, right?
Excuse me, sir.
Yes, yes, yes.
Sir, PIC 16 F84 එකද use කරන්න ඕනේ?
No, no, pick 16F 887, right? Pick 16F 887. The same pick that we have used last time. Yeah, can you see it in here? Pick 16F 887. Pick 16F 887. That's the one you have to use, right? So please tell me if you don't understand anything, and you can see the screen, right? Okay, so there's more to this code, right? So first complete this part, then I will tell you what to do next, right? So don't try to do everything together, right? First open micro C, then just type these things by understanding, right? So there are few other codes as well, one or two few lines, right? 5 or 6 lines, so we have to write those things as well, right? So if you have finished with this, please tell me, so I will go to next slide, right? Uh, do you need more time for this one? Here, this test constant that can be any value, right? So if you are finished with this, we can go to next one. Shall we move on to next slide? Yes. Okay. So in next one, right? In here, right? I am just typing this thing, right? Option register b dot b5 bit 5. I'm assigning it as 1, right? Why is that? Yeah, this is bit 5, right? Uh, this is bit 4, right? So bit 4. Sorry, bit 6. Sorry, bit 5. This is bit 5, right? I'm selecting this transition on T time 0 clock input pin, right? That means RS4. Right? So I'm selecting only that one, right? We'll check these things afterwards, right? Yeah, if you keep it like this, you will get an error, right? Because yeah, you cannot keep it just like this and this, right? So if you are keeping it, you have to comment these things. So in here, these things you have to comment because we are not assigning any values, no, right? So we'll see by assigning values afterwards, right? But for now, we will keep it as it is, right? So we will not, so b0, b1, b2, these are prescalers, and b3 select the prescaler to watchdog time or timer 0. Before is the rising edge or falling edge. So without putting any values to this, we will keep it as it is. Actually, you don't need to type these things, right? We will type these things afterwards. So just type this one. Option register this one. This why it is counter time 0. This is um, pulses. Yeah, this is pulses to RF, right? Only that one is needed. These things we can keep by as a comment, right? As a comment, then we can check whether these values are working as we have learned previously. Okay. right? Then, so remember, we are not going to hide these things, right? Why? uh, because we actually we can type these things, right? But make sure to comment them. Why? Because we are not assigning any values. Okay, so at default, as I have told you previously, one clock pulse should, yeah, default one clock pulse should be, yeah, one clock pulse, um, one clock pulse should be, um, yeah, one clock pulse is one incremented by one. Okay, then next one, what we'll do is after that, yeah, first, um, time 0 we will reset. Why? Because we need to count our values. If time 0 has the value, so it won't be correct, right? Then while one loop, right, what we are going to do is, if time 0 is equal to test means the value that we are setting. So previously we have set the value as 5, right? What we need to do is port B 0, that is with 0 pin, we will make it as 1, then close it, right? So type this one as well. Okay, so if you have finished with that, okay, next, if you have finished with that, so you can make this one, right? Right. Okay. So how can you make here? First, go to where you select components in here, right? Here, uh, so here, right? In here, right? Go to where you select components. So then type button, then LED. LED is not needed, right? LED red, then pick 16 F887, then a resistor, then a switch. And actually switch is also we don't need, right? We need only button, this push button, LED red, right? And this pick 16 F887, then a resistor, right? So then you can make this arrangement, right? As I have explained you previously. Okay, so I finished with creating this Proteus file. So here these things you don't need, right? This part you don't need. You just need this push button, then this LED connector. Okay. Okay, so then we'll see whether this works, right? So uh, so here initially this is at 0 volts, right? 0 volts. So then what will happen is when I press it, it will go up, right? Mm, Then I release it, it will go to zero again, right? So like that. Okay, check whether it works as expected. So here 1, 2, 3. By 4 it presses. So check again. Right. So by when I press this, so can you see that 4 times it will switch on, right? So maybe for this one I have put that program, right? So change that value, right, for test, then see whether you are getting the same thing, right? So check whether you are getting the same thing, right? So here for this one, the program I have previously put this thing, right? So yeah, I have previously executed that one. Previously executed that one. So okay, yeah. So check whether when you press it 5 times, you are getting the required result. Right. So check that one as well, right? So almost all of you should get the correct answers, right? Check it. mm, Check this one, right? So yeah, this is working. it counts like this, right? Can you see? So if I press this again, it will not change because this is already one, right? Okay. Yeah, so check that one by yourself, right? So any questions? Any questions? Okay, so if you don't have any other questions, we'll stop for today, right? Okay, we'll stop the recording now. Thank you.